Hi guys, good morning, welcome. So we're starting a bit late. We ran a little bit late with my other group. So if you could start with some green check marks, please, just make sure everything's still working. And then we'll continue on with where we left off last day. So if you recall, we finished up the material from Unit 3. And I know, I think one or two of you submitted your learning guides over the weekend. And Kaylin did point out that I had the file upload size too small. So I think it was 1 megabyte, which is obviously like nothing. So he couldn't get it uploaded. But thank you, Kaylin, for sending me a message. And now it's at 100 megabytes. So you guys can upload as much learning guide as you want. I will start with any questions you guys had. You can't hear me. Is anybody else having issues hearing? Yeah, I think no, Mr. Ross can hear me in his headset. So I'm thinking, Costin, just you. Maybe try the audio setup wizard. That might help things out. Of course, you can't hear me. There's no point in me saying that. Anthony can hear him? Question mark? I don't know what that means. I can hear him. I can hear you. All right. Do you want to throw in green check marks? I have one from Anthony, but nobody else. It's just a little easy way for me to see that everybody's good. Obviously, Costin can't hear me, so he's not going to give me a green check mark. But if you can hear me, that green check mark goes a long ways in showing me that. Perfect. Costin's going through the audio setup wizard. Josh is MIA. It's okay. All right, we left off last day. I did some examples in the learning guide. We were talking a bit about converting imperial, metric, volume, stuff like that. And then the very end of the learning guide was just a bunch of questions. Now there was tons of them, and I said, you guys don't need to do all this. So I crossed a bunch of them off, and I was hoping you guys would come back today and have some questions about the questions. So if anybody has anything that they would like me to go through, what you can just do is, I know there's no page numbers on this learning guide, but you can write like the section putting it all together. I think the questions just count up. So you could just literally write in the question number, and I could do it on the board here in front of you guys. If you had a question about it, it's likely that other people probably experienced difficulties in the same thing as well. So it never hurts to ask. If nobody asks any questions, I'm just going to assume that you guys are experts and you will have this learning guide submitted by the end of the day. And I'll actually just move on to the next unit, which we're going to take like 2 steps backwards, and we're going to go to Unit 1. We're just going to start from the beginning. Number 16 for sure, Emery. I could do the 16. It's a bit of a tricky one. You probably don't see a ton of those. I kind of like 16 though. It's kind of sneaky. All right, just one question. That's scary, but that's okay. We can work with that. All right, so it asks us to find the area, and I'm sure if we looked at online, you could find some fancy formula to calculate the area of this. But the key thing is, it's kind of like these composite shapes types questions where you have 2 shapes put together. I don't see any here. So what you need to do is you need to kind of break it down into 2 shapes that you can find the area of. So I don't even know, I guess it's it's not a rectangle, it's a quadrilateral maybe, 4 sides. But I don't know the formula to calculate the area of it. So what I'm going to do is, if I draw a line just straight across like this, it's going to break down into 2 shapes. I'm going to have a rectangle down below, and I know the dimensions of my rectangle are 8 by 14. And up at the top, I'm going to end up with this triangle. And the triangle, I know a little bit of information about it. I'm just going to redraw it. I know that the bottom is 14 because I can just translate that 14 up. This part over here I don't know, but I can figure it out because I know this side is 8 and this whole side is 12. So if the whole thing is 12 and I know this much of it is 8, that's going to leave us about 4 left for that side. I'm going to get rid of all that mess now. All right, so if I draw the line across, I have a rectangle that's 8 by 14. So I'm going to have the area of my rectangle, draw it like that, and then I'm going to have to add to that the area of my triangle. Now my rectangle is just going to be length times width, and my triangle is going to be base times height divided by 2. My length is 8, my width is 14. And then my triangle, I have a base of 14. My height is 4, and then I'm going to divide it by 2. So I'm going to just do this in 2 steps on my calculator. I'm going to do I'll just rewrite everything up here. I can do this first step here, 8 times 14. That's 112. And then I'm going to add to that 14 times 4 divided by 2. So 14 times 4, hit equals, divided by 2, equals 28. 112 and 28 is 140. Now, the one sort of tricky thing is that it didn't indicate what units I was dealing with. It just says there's a field, it's 8 by 14 and 12, determine the area. So I want to kind of express that this is an area. I have 140 units of something. So what I'm going to do is I'm just going to write units. I'm going to put a little squared next to it, just to remind myself that I'm dealing with an area. So if I don't have units, I can just write the word units. I don't know what it is. It didn't give it to me in the question, just units squared. There we go. Hopefully that helps you out a little bit, Emery. I think Costin might be still having issues. Hopefully you can get those sorted. It looks like he logged out. Maybe re-logging in is going to help him. All right. I did print off the next learning guide to go through a few of the questions, and if you can see how thick it is, it's like 36 pages. And mine printed single-sided, so this is literally 36 pages of learning guide. So it is a long one. If you guys don't have paper and ink for 36 pages, just send me a message. I'll print you off one. It takes me about 2 seconds. It'll be waiting for you here. You don't even have to talk to me. I'll just leave it at my desk and just come and grab it and run. And totally understand, because that's a lot of paper. I did try to shrink it down, but it just wasn't working. How are we doing, Costin? Can you hear me? I'm just gonna, oh. It's asking about number 14. Can you hear me? Can you see me dancing? No, we're not good? Oh. You just have no audio? Okay. I can still do this. Just have to type a little bit while we do it. Too bad Costin doesn't know any sign language. Or maybe he does. I don't know any sign language. Walking lights are placed around the perimeter of a rectangular garden 30 feet by 16 feet and are placed 18 inches apart. How many lights are needed? Okay. Let's draw a picture. And draw a smaller picture. All right, so this is 30 feet by 16 feet. Should probably write that this way. "30 feet, 16 feet. What if the problem I'm running into here is that it says that the lights are spaced 18 inches apart, but I'm given distances in feet. So what I want to do is I want to convert my feet into inches just to make my life a little bit easier. Now you'll remember hopefully that there's 12 inches in a foot. It's one of the imperial measures I do know. And I'm just going to rewrite this in terms of inches. So I'm going to go 16 times 12 because each foot is 12 inches, which is 192 inches. So this is 192 inches. And then 30 feet times 12, 30 times 12, it's pretty straightforward, but I'll do it in my calculator anyways. This is going to give me 360. There we go. So if I want to place them 18 inches apart, maybe this is what I'll do. Let's just imagine for a second, I just cut this corner here, and I'm going to take this whole perimeter, the 360 by 192 by 360 by 192, I'm just going to turn it into a big line. Guess there's no rules against that. I'm going to have my start here with my first light. I'm going to have 360 inches, and then I'm going to have 192, and then I'm going to have another 360 plus another 192. That's kind of what it's going to look like if I unwrap that whole perimeter. So what I'm going to do is I'm just going to think, well, does it matter if it's a rectangle or if it's just a line? Not really. It's just I need a light every 18 inches. So if I just added all these distances up and divided by 18, that should indicate how many lights we need. So that's what I'll do. I'll just go 360 plus 192 plus 360 plus 192, just taking the perimeter. Let's see what that equals. 360 plus 192 plus 360 plus 192. 360, 360, 192, 192. 1104 is the total length. So that's 1104 inches. Okay? Now I need a light every 18 inches. So I need to take that 1104 inches and I'll just divide it into 18. See how many times 18 goes into that. So with my calculator, I just have to go divided by 18 and it just takes that answer. And I get 61 lights. And of course it was a decimal, so the 18 doesn't fit in there perfectly, but it is pretty close. So 61 is going to be good. All right, is there anything else from the end of that learning guide that you wanted me to go through? If not, I'll just continue on to Unit 1. while you guys are thinking. So this is our course, the top of the page. Looks like I have some messages to answer. You can see that Unit 1's now open, and the Unit 1 learning guide is right here. There's only 4 lessons in Unit 1. The first one's, well, they're all pretty long. But they're not terribly difficult, which is kind of good. Number 18. I can look at that too, Costin, for sure. So maybe while I'm going through number 18, if you want to print out the learning guide at home, even if you just printed out a few pages, I can print out the rest for you at school just to get you going for today. We'll likely get through, it sounds like a lot, we'll probably get through about 4 pages today, maybe 5. The whole lesson 1 is 8 pages of this 36, so it is a lot. So if you just print off the first, 5 or 6 pages, you should be good, and then you can come in and grab the rest, or just print the whole thing if you're up for it. And I've probably mentioned this before, but we kind of get into this kind of weird limbo land where some of you guys are trying to finish up the Unit 3 stuff, and then now I'm moving into Unit 1. I mean, normally the units will be chronological. We'll go 1, 2, we'll skip 3 and go 4, but kind of going backwards now. But it's really, really important that you stay current with the material. We've had lots of time to do this Unit 3 stuff. It needs to be in, you need to write the test, because in class already today I'm going to start on Unit 1. And we don't want you to be doing Unit 3 stuff and Unit 1 stuff at the same time, because that's going to get confusing. And now you're trying to do 2 things at once. So get the Unit 3 stuff out of the way. Get it done. Work hard on it. Finish it before next class for sure. And then you can focus on the Unit 1 stuff. So Costin, I'll get to that question for sure. Number 18. And then I'm going to jump into Unit 1. So make sure you have your Unit 1 stuff ready. All right, so we were asked to calculate the surface area of a square-based pyramid. So we're going to have the area of the base is going to be b squared. And then we're going to have the lateral area. Let's just jump over to our formula sheet, make sure I don't mess this up too bad. Okay, so the surface area is going to be 2 times the base times the slant height plus b squared, or the base squared. 2bs plus b squared. Now, sorry, clicked on the wrong thing. I'll write it the same way. 2bs plus b squared. I should label things here just so we're clear. This 9 is the base, and this 14.4 is the slant height. So 2 times the base, we're calling the base 9. And then the slant height, we called 14.4. And then I'm going to add to that this 9 squared. I'm going to do this in 2 steps. I'm going to do the 2 times 9 times 14.4 first. So 2 times 9 times 14.4 gives me 259.2. And then 9 times 9 is going to give me 81. So I'll just go plus on my calculator, 81, 340.2. And my units were meters, and I found the surface area, so it's meters squared. Calculate the surface area, use pi in your calculator for all calculations. Yeah, so that's good. If it was just so easy, Kalen, to just press print and everything came out nicely, then everybody would do it. Technology's got to challenge us from time to time, else we would just rely on it and use it for everything in our lives. But yeah, these things happen. Just like I can't get my Blackboard to go full chat or full screen or anything. It is what it is. All right, I'm going to leave that there. I'm going to assume you guys are good to go on Unit 3. Get it done. The expectation was that you guys will be done this tomorrow. So Unit 3 Learning Guide will be in, and tests will be written by the end of the day tomorrow. Remember, if you submit your Learning Guide today at the end of the day, I won't get to it until tomorrow morning. So I won't even have that test password out to you until tomorrow. So if you submit your Learning Guide at the end of the day tomorrow, you won't get your password until probably the end of the next day. You got to give me about a day to get the passwords out, get your Learning Guides marked. I'm going to jump into Unit 1. And just like Unit 3, we're going to kind of go through some of the examples, and then I'm going to get you guys to do the try these. But this section's a little bit, I don't want to say easier than the previous section, but it's a little bit easier than the previous section, which is kind of nice. So basically the idea behind this unit, it's called Unit 1, Unit Pricing Currency. It's kind of stuff you use in your everyday lives. And unit pricing is really, really handy. And I use it all the time. And one of my favorite places to shop is Costco. Who doesn't love Costco? You go in there, samples, they got everything you could ever want. It does get a bit chaotic, but it's a good place to shop. And the reason I love Costco, this sounds really kind of silly, but on every sign in Costco, every price little tag, it tells you the unit price of everything. And what do I mean by that? Next time you're at Costco, look, you can walk in and be like, okay, say you want to buy some toilet paper. Everybody buys toilet paper at Costco, cheap, get a big jumbo bag of toilet paper. You can look on each of the little tags, and it says on each of the tags, the cost per sheet of toilet paper, like little square, or cost per roll, just depends on which one, or like paper towel, cost per sheet. And you can compare the costs of different ones. So you imagine like you get a big 30 pack of toilet paper and each roll has like 150 sheets, or there's like a 45 pack of toilet paper and each roll has, like 100 sheets. And you're thinking, well, this one's 20 and this one's 35. Which one's the better price? You can look on the little tags and it says price per sheet, and you can just directly compare it. Everything, granola bars, you go to the front, it tells you the cost per granola bar. You have like a 12 pack, a 48 pack, you have to just compare them directly. So that's kind of why we talk about unit pricing and currency and all this stuff, because it does become important for sort of everything you do. So let's just jump through this stuff, hey? The three kind of vocab terms that come up a lot are rates, proportions, and ratios. And we need to kind of distinguish the difference between these things. So ratios are two numbers that have the same units. And we're going to compare them. So we can write 30 and 40 as a ratio as either 30:40 or 30/40. So we can write ratios as a fraction, or we can write them with a colon in between them. Proportions a little bit different when we have two ratios or rates that are the same. So I could say 30/40, or that's equivalent to 3/4. So that's a proportion, 3:4. They're the same. They're equal to one another. And then we have rates. And rates, again, are different. Rates are when two numbers with different units, different unit measurements. are compared. So what do we mean by this? Well, if I said the gas was $1.16 per liter, hopefully gas never goes to $100 per liter. I wouldn't be able to drive, that would make me very sad. Or when we talk about milk, people are just, well, how much is a jug of milk? Well, it's $3 for a jug. How much milk is there in a jug? Well, it's 4 liters. So you have $3 per 4 liters of milk. That's a rate. So ratios, two numbers have the same units and we compare them. Proportions are kind of things that are the same. And then rates actually have different units. So we have dollars per liter, miles per gallon, candies or cost per candy, things like that. Those are rates. And then we'll talk a little bit about unit rates later. So try these, you either have a ratio, rate, or a proportion, and you need to kind of just, go with it. So maybe I'll do the first couple here, and then we'll see how we go. This 5 to 9, this is just a ratio. I don't know what the units are, but it doesn't really matter because they're the same. This next one is $30 per kilogram. Notice I have dollars on the top, kilograms on the bottom. This is going to be a rate. Cost per kilogram. The next one here, 2 to 3 is equal to 6 to 9. These are the same thing, 2 to 3. If I multiply everything, by 3, I end up being able to convert from 2 to 3 to 6 to 9. And this is what we would call a proportion. So that gives you a bit of an idea what these things are going to look like. Letter D, as soon as I see dollars and liters, I know that this is a rate. That is the cost per liter. I see the little colon in here, and I know this is a ratio. And then this is just a fraction, so this is a proportion. Another ratio. All right, I'll leave 5 and 6 for you guys, and 7. Can try those later. I want to keep moving. Number 8 at the top of the next page asks what the LCM. And the LCM is something that's going to come up a lot. We're going to talk about it. And we should kind of define what it is. I guess there's kind of 2 different ways I've seen it written as. I've seen it written as least common multiple. The course here uses lowest common multiple. So lowest common multiple or least common multiple are the same thing. So we're trying to figure out the number that goes into essentially both things. So if we have 3 and 12, looking at example 9 down below here, what's the least common multiple of 3 and 12? So what we're going to do is think of a number. I don't know what the number is, but we need to be able to divide that number by 3 and by 12. So I'm going to just do the first one, and maybe you'll kind of get where I'm going from here. If the number, the magic number I'm thinking of, the LCM, is 12, does 3 go into 12? Yep. 12 divided by 3 is 4, which is a whole number. and 12 divided by 12 is 1, which is a whole number. When it says divides into equally, that's what it means by that. So the least common multiple of 3 and 12 is 12. Now all of these are kind of set up to be kind of similar. The least common multiple of 13 and 26 is going to be 26, because 26 divided by 13 is 2, and 26 divided by 26 is 1. So 26 is the least common multiple of 13 and 26. 2 and 8, same thing, is 8, because 8 divided by 2 is going to give us 4, and 8 divided by 8 is going to give us 1. Things get tricky when we get to letter D. Normally, we've had these two numbers, we just pick the biggest one. The first one was 12, the next one was 26, the next one was 8. What if I picked 3? 3 is bigger than 2 if we kind of just go by that rule. So if I say, okay, maybe the least common multiple of 2 and 3 is 3. 3 divided by 2 gives me 1.5. And that isn't a whole number, so that's not going to work. Can anyone think of the least common multiple between 2 and 3? It's the smallest number that both 2 and 3 can divide into equally. When we say equally, we just mean kind of an integer number of times. So we don't want to have any fractions or decimals or anything like that. So it's not 3. 3 doesn't work. 1. But they both, like, you want to think of it this way, Costin. If I go 1 divided by 2, I get 0.5. So you want smaller because 1 goes into both of those things, but you kind of got to flip the way you're thinking about it, and you got to think about a number that the 2 and 3 go into, not a number that goes into 2 and 3. Kind of sounds confusing, but hopefully that makes a little bit of sense. So the smallest number that both 2 and 3 can divide into. And there's a bit of a trick. It doesn't always work, but you can get a common multiple of numbers. This word multiple kind of sounds like multiply. So if you absolutely need to find a multiple of two numbers, what you can do is just multiply them by each other. And that works here. So the least common multiple of 2 and 3 is 6. Why does 6 work? Well, 6 divided by 2 is 3, and 6 divided by 3 gives me 2. So 2 and 3 multiply together to give me 6. Hopefully that makes a bit of sense. If I had 4, if I go 4 divided by 3, I don't end up with a whole number, so that's a problem. We'll see where this kind of becomes important here in a second, but for now, if you're just kind of like, Mr. Borden, you lost me, that's fine. We'll look at some examples that have LCM in action. All right, write the following ratios in simplest form. This is the same thing as simplifying fractions. You look at the numbers and say, is there anything common to both these things? So the first example, you have 5 and 30. What's a number that goes into both 5 and 30? And how many times does it go into each? So for the first example, 5 and 30, the biggest number that goes into both those things is going to be 5. And what I do is I just say, okay, I'm going to divide this side by 5, and I'm going to divide this side by 5. And what do I end up with? Well, 5 divided by 5 gives me 1, and 30 divided by 5 gives me 6. So if I had a fraction like 5 over 30, you could do the exact same thing and you would write this as 1 over 6. Ratios can be written as fractions, or they can be written as a ratio with that colon in between them. Let's do the next one, and then I'll give you guys a chance to do a few of these. So 14 and 18, going down the list here, 14 and 18. The biggest number that goes into both 14 and 18. So I start thinking, okay, well, 7 goes into 14, but 7 doesn't go into 18, so that doesn't work. Are there any other numbers? Like 3 won't go into 14, 4 won't go into 14, 7, 9. 9 doesn't go into 14, but 9 goes into 18. So we're kind of getting on the right track. We're getting closer maybe. How about 2? Does 2 go into 14? Yep, it goes in 7 times, and 2 goes into 18 9 times. So if I want to figure out how to simplify this, if I had a fraction that looked like 14 over 18, I could divide the top by 2 and the bottom by 2, and that would give me 14 divided by 2 is 7, and 18 divided by 2 is 9. And I know I've got the right number because I can't simplify it any further. There's nothing common to 7 and 9. These are 7's prime and 9, a 3 can go in there, but it doesn't go into the 7. So that's kind of as simple as that one gets. Maybe we'll do C, and then I'll let you guys do the next 3. 18 and 30. 18 and 30. And same deal as before. You can write it as a fraction if you want, if that makes more sense for you to see it written as 18 over 30. All right, biggest number that goes into 18 and 30. So I start thinking of numbers that goes into 18. Well, 2 is going to work. It's going to give me 9 over 15, but then I can go a little bit further. So maybe let's think about that. Let's divide the top by 2 and I get 9. And I divide the bottom by 2 and I get 15. So 9 over 15. Is there anything that goes into 9 and 15? You can see how I could do this in several steps instead of one. There's nothing wrong with that. 9 and 15, 9 and 15. Well, 5 goes into 15 and 3 goes into 15. That's it. So 3. 3 goes into 9 3 times. 3 goes into 15 5 times. So I can simplify this to 3 and 5. I'll leave D, E, and F for you guys to do. I'm just going to keep plugging away. All right, we're going to look at solving these types of examples here. We're going to look at 11, and then we're going to look at 12. And we're going to do the same type of question 2 different ways, and you can just figure out whichever way you like the best. I personally like the cross multiplication thing that we're going to do in number 12, but if you like the first one here that we're going to do in 11, that's fine. There's nothing wrong with that. So it says determine the following proportions by finding the unknown number. So there's an x in each of these questions. We need to figure out what x is. It says by using the LCM, or the least common multiple, or by finding an equivalent fraction. Show all your work. So what we need to do is just kind of think about what the x is, because we know that it's equal to the thing that's written next to it. So if I had 6 over 24 is equal to 12 over x, they're the same. They're equal. They're equivalent. That means they're the same. That equal sign means whatever's on one side is the same as whatever's on the other side. So let's think about it this way. It's kind of something I can do. What do I have to do to a 6 to get a 12? What sort of mathematical operation am I doing there? And we're not adding or subtracting, so we want to kind of exclude all addition and subtraction type stuff. We're multiplying or dividing here. Technically, 6 divided by 24. So if I did something mathematically to a 6 to get a 12, what am I going to do? So Costin says multiply by 2. For sure. 6 times 2 gives me 12. Now on the bottom, if I have a fraction, if I do something to the top, I have to do it to the bottom. If I do it to one side, I have to do it to the other. So if I multiply the top by 2 to get from one side to the next, I have to multiply the bottom by 2. So if I had 24 and I multiplied it by 2, That means that our x has to equal 24 times 2, which is going to give us 48. So x is 48. All right. Letter B is almost the same, except it's flipped. I have the x on the left instead of the right, and it's on the x on the top instead of the bottom. So I can think about the same thing. I know what this is, 9 over 2. If I really want, I could plug that in my calculator and get 4.5. So I have 4.5 on this side. I need 4.5 on this side. So you can think about something divided by 16 is 4.5. Well, that's confusing, so I don't like to think about it that way. But I can think about it this way. What do I have to do to 2 to get 16? And if I do it to the 2, I have to do the exact same thing to the 9. So in the first example, we were multiplying by 2 to get from 6 to 12. Now what are we doing? Well, we're going from 2 to 16. So what is this mystery number? If I multiplied the bottom by 8, multiply the top by 8. 2 times 8 gives me 16. 9 times 8 gives me 72. And you can do that for all of these questions. They should all work out fairly nicely. So far, the first two examples were kind of like multiplication type ones. We had to multiply. If we look at letter C here, it's something like that, but it's a little bit different. I started with a 6, and I'm going to a 3. What do I have to do to a 6 to get a 3? And that means I'll have to do the same thing on the top. So instead of multiplying, I can't multiply 6. Well, I technically could, I guess. I could multiply 6 by a half. But I kind of think about it in terms of division. If I go 6 divided by 2, I go from 6 to 3. So if I do it to the bottom, I can do it to the top. So that means 4 divided by 2 is going to give me 2. All right, I'm going to leave you guys the rest of the try these for next day. Hopefully you can go through those. Number 12 is kind of the method that I'm going to show you that I like the best. It's just the easiest for me. And when you have sort of basic questions like the ones that we've looked at here, that proportion, if I multiply the top by 2, I multiply the bottom by 2, it all works out. But things are going to get a little bit more complicated, and it just kind of, this next way to do it, number 12, we call it cross multiplication, it's just going to work all the time, and it's just going to make our lives easier. So this is the way I like to do these types of questions. So solve for x by cross multiplying. All right, cross, think about a cross. I guess there's no real easy way to do this. I'm just going to show you a few examples, and then hopefully you guys can pick it up. So what we do when we cross multiply, we take the top on one side, and we multiply it by the bottom on the other side. And we take the top on the other side, and multiply it by the bottom of the other side. So it kind of looks like this. We take this 3 and multiply it by the x, and then we take the 8 and multiply it by the 7. So it looks like this. We're going to get 3 times x, because that's the top on this side multiplied by the bottom on the other side, is equal to 8 times 7. So 3 times x is 3x. 8 times 7 is 56. And then we're going to have to get rid of the 3 on this left side. So I want to divide both sides by 3. So on 8 times 7 is 56 divided by 3. That's 18.6. So we'll just leave it as x is equal to 56 over 3. We don't want to write it as a decimal. We'll just leave it there. I know I probably caught one or two of you off guard there. This one makes no sense, so we're just going to get rid of it. There's no x there, so we can't really do it, just a typo. Letter C we can solve, though. So remember, I can rewrite this in like color coded if you want. 12 over x is equal to, trying to think if this color code will work, 5 over 8. So what I'm doing is I'm taking, I didn't really want to do it that way, but maybe it'll be easier. I want to take the top on this side and multiply it by the bottom on this side. So I'm going to go 12 times 8, and that's going to be equal to the top on the other side multiplied by the bottom, 5 times x. All right, so on the left, 12 times 8, 80 times 2 is 96, is equal to 5x. I'm going to have to divide both sides by 5 to get rid of the 5. And I have 96 over 5 is equal to x. I'm going to leave all the try these for you guys to do because I want you guys to practice this cross multiplication. I know it looks like more work than the previous one, but I assure you it'll be a lot easier in the long run because cross multiplication just works all the time. For the previous one, we used kind of proportions, or saying if I did this to the top, I have to do this to the bottom. You run into problems because it's not always going to be a nice whole number. It's not going to go from 2 to 4. What if it went from 2 to 72? What did I do to 2 to get 72? Well, I have to multiply by, like, you know, then you start getting into decimals, and it's just a bit of a mess. So cross multiplication, even though it's 2 steps, it'll just work all the time. That's a really great question, Costin. Do you actually divide the 96 by 5, or you just leave it? We're just going to leave it, because if I divide 96 by 5, I get a decimal, and unless the question asks for like a decimal answer, I'm usually not interested in having decimals as answers. So if there's something I can do to simplify it further, if it was like 100 over 5, I'd go, okay, 100 divided by 5 is 20. But that's not the case here. So yeah, we just leave it as a simplest fraction, 96 over 5. And there's nothing we can do to simplify that any further. There's no common number between 96 and 5. Nothing I can simplify out top and bottom. So I'll leave those, try these. There's a few more. I kind of just want to, I know I'm kind of cruising along here today, and I apologize, but there's 36 pages in this unit, and it'll literally take us forever to get through it. So this question number 13, this sounds ridiculous, but I do this at home all the time. I have a chainsaw that I use to cut firewood and stuff, and the actual question is the exact same as my chainsaw. I also have a weed eater whippersnipper thing, and they're 2-strokes. Engines, so that means that they need to mix the gas and the oil. The engine cycle just has 2 strokes to a cycle instead of a regular like car engine's 4-stroke. I don't know if you guys know the difference or not. But anyways, 2-stroke engines, they need oil in the gas to make them work. And different things will have different mixes. Like I have a boat motor, little like 9 horsepower boat motor. It's 30 to 1. So 30 parts gas to 1 part oil. My whippersnipper and my chainsaw, those are both 50 to 1. So when I mix the oil and gas, you have to just mix them in different ratios. So that's what this question's talking about. It's talking about Mike. He owns a landscaping business. His equipment requires a mixture of 50 parts of gas for 1 part of oil. And you could just imagine me sitting in my garage looking at this like jerry can of gas and thinking, okay, how much gas is in there? Okay, and then I have these oil, the oil comes that I can either have like a big 1 liter, so I have to measure it out, or sometimes I have little 100-liter things, so I have to think, okay, now I have to do some math to get 100, and it's complicated. It's not just like easy sometimes. So that's what this question is talking about. It says the ratio of gas to oil is 50 units of gas to 1 unit of oil. It says he's got a 5-liter can, or 5 liters of gas, and he needs to know how much oil to add to it. So what we've done is the ratio of gas to oil, we've written it as a fraction, 50 to 1. So to kind of simplify this, instead of this 50 to 1, I'm just going to write this as 50 divided by 1. Now, he has in a can, he has 5 liters of gas, and we need to figure out how many liters of oil we need to add to it, or X. So all I've done is I've taken this ratio from here, and I've just rewritten it. So 50 to 1 is 5 over something. 50 parts gas to 1 part oil. I have 5 liters of gas. How many parts of oil do I need? Now you'll notice this kind of looks exactly the same as all of the questions we just did. And I'm going to encourage you to use cross multiplication to solve it. So I'm going to go top on one side times the bottom on the other, which is going to give us 50 times X. And then I'm going to go the top on the other side times the bottom. This is why it's called cross multiplication, because you're going across. And if you draw these arrows in, you kind of end up with this cross in the middle. Cross, it's like an X cross, get it? So this is going to be 5 times 1. All right, I'm going to get rid of the brackets here. I'm going to get 50x, and 5 times 1 is just 5. All right, I want to get x by itself, so I'm going to do the opposite. It's going 50 times x. The opposite of 50 times x is going to be dividing both sides by 50. 50 divided by 50 gives me 1. And I'm going to have 5 divided by 50. Now, I can simplify this fraction to 1 over 10. And if I just plug that into my calculator, it just equals 0.1. And we started off with liters of gas. We started with 5 liters of gas. So that means I need 0.1 liter of oil. I guess I could write that in, of oil. But 0.1 liters of oil might be a little bit confusing. So I can convert it, and that's what's happening right here. You can convert it into milliliters. So I'm going to multiply by 1,000, which is 100 milliliters of oil. So Mike would need 0.1 liters of oil to mix with 5 liters of gas, which is the same thing as 100 milliliters of oil. So Costin, you asked the question before, do we change the 96 over 5, or do we just leave it? Well, in that case, we didn't really know what the units were, the 96 and the 5. It didn't really make sense to write it as a decimal and get whatever it was, like 19 point something. But in this case, we need to tell this guy, Mike, how much oil to add. So 0.1 makes more sense than add 1/10 of a liter. So kind of the context of the question will indicate whether you want to convert it or not to a decimal. So just kind of use your best judgment. All right, I think we're gonna just quit there for now. You should be able to do the conversions for the try these here. And I think you should be able to do to the end of here. So we're gonna stop, this is October 18th. All right, so what I would like you to do for next day, well, first of all, I would like it if you guys submitted your Unit 3 learning guides. I'll get your passwords out so you can write the Unit 3 test before next class. Do not drag this out. I will get angry if you have not written the Unit 3 test by next class, which is going to be on Thursday again. You also need to finish the first 3 pages of this learning guide. So as I was going through, I left some of the try these questions for you guys to go through. So I want you guys to go through those. Do your best. If you run into problems, ask next day. I can help you out. There's some more over here in question 10, a couple on the bottom of page 2 that I left. So you should be done up to the bottom of page 3 by next day. Now I know that seems like a lot of work, but really your Unit 3 learning guide should have been done today anyways. So that was kind of the hope that you guys would finish off the Unit 3 learning guide. Costin just reminded me that on Wednesdays you can come in from 1 to 3 and get help. I think I'm free tomorrow afternoon, so I'll be here. If I'm not here, Mrs. McIntosh is here, and she's really smart too. She does the grade 7, 8, 9 math, but she's taught grade 10 and 11 math as well on 12 math, so she'll be able to help you out. But I'll be here tomorrow. And McWilliams, if you need help on the Unit 3 stuff, if you're running into issues and you want a little support, you can come in. You don't have to stay from 1 to 3. You can just come in for an hour or half an hour or whatever works best for you. But just know that you can come in anytime. But don't show up at like 2:50 and just expect me to sit around and help you for the next hour. I have to go places. I got things to do, work to do. So if you can find help outside of school, awesome. If you want to come in for help from me, you can do that tomorrow anytime between 1 and 3. And you must get this Unit 3 learning guide in and the Unit 3 test written before next day. We do not want to drag out Unit 3 any longer. We need to get it done. So I'm going to leave you guys there. Next class, you should come with questions, anything you ran into in terms of the first 3 pages of this Unit 1 learning guide. If you want me to print off a learning guide for you, just send me a message. That's kind of it. If nobody has any questions, we'll call her a day, and we'll see you guys again on Thursday. And remember, there's no field trip this Friday because we have professional development day on Friday. All right, so I don't see anybody typing. I'll leave you guys there. Have a great afternoon. We'll see you on Thursday. And yeah, take care. Bye-bye.